Hello, my beautiful computer science students. Welcome to another AP CSA lesson where I, Goldie, take you through Unit 3, Boolean expressions and if statements. Today's lesson is going to be a lesson on short circuit evaluation. And we're just going to talk about quickly what it is and an example of it. Okay. So short circuit evaluation is a concept where the compiler will skip over pieces of a logical expression when you already know what the outcome will be. And there's reasons why this might be useful in a program. Really, it comes down to just being able to have more efficient code. And you might not think of any examples where you can use it in your program until you reach a more advanced level. What I want you to do right now is just recognize when it's being used. Okay? And that's really the goal of by the end of this lesson is just to recognize, I can recognize that that's being evaluated with a short circuit evaluation. So how do we know what a logical outcome will be without evaluating the whole thing? Well, we just talked about the Boolean operator AND, okay? And compares two expressions or two Boolean values. So let's say I have an expression that comes first, expression 1, and let's say that expression 1, when it's evaluated first, it determines that it's false, okay? If it's determined that it's false, it doesn't matter what expression 2 is, because with the logical operator AND, as soon as one statement is false, the entire thing is false. So because it doesn't matter what expression 2 is, the compiler will actually not check expression 2. Okay? Once expression 1 is false, it won't even bother with the second expression on the other side of the AND. It'll just evaluate the whole thing as false. Okay? And then the same idea happens with the OR. Okay, so let's say I have expression 3, expression 4, right? So expression 3, I evaluate that first. If it's determined that it's true, logically, the whole expression will be true, no matter what expression 4 is. Okay, that's the OR logical Boolean operator, right? If expression 3 is true, then the whole thing is true. Doesn't matter what expression 4 is. So because of that, the compiler will not check expression 4. Okay. So those are the two short circuit examples. And here's an example of how you can take advantage of this. Okay? So if I have the little code segment, if x is not equal to 0 and y divided by x equals 2, x is half of y, right? So I have and this gets evaluated first, that expression. So if x is not equal to 0, if that's false, if x is equal to 0, this never gets checked. Now, why might we not want that checked if x is 0? Well, because I have this divide by, right? And I can't divide by 0, I'll get a runtime error. So if x is not equal to 0, if that ends up being false, I don't want this checked because that's going to crash my whole program. Okay? So because of this, I can use short circuit evaluation. So if this ends up being false, then this never gets checked and I never have a runtime error. I never have my program crash. Okay. So that's an example of it being used and how it could be helpful to avoid program meltdowns. But just know that it does take advantage of short circuiting and it won't check that second expression. Okay, that's really all I want you to be able to do on the AP exam is recognize when it's being used and in like a situation like this, why it might be helpful that it's being used. And that's the end of it. Shortest lesson ever. I love it. So we just talked about short circuit evaluations, which falls under the compare and contrast Boolean expression learning target. So thank you again for watching, everyone, and have a great day.